Welcome back, guys. In this second video, we're going to be defining all these pieces. So all of these that you see down here, we're also going to be creating their prefab. And then finally, we're going to be spawning them and positioning them. So once we start playing the game, this shows up. So now we have all our pieces exactly where they should be and ready to fight. So that's what we should be getting by the end of this episode. Without further ado, let's get started. Cheers. This next video is all about creating pieces and spawning them and then positioning them. So we're going to have three sections in which we create the piece, their type, and their prefabs. Then we're going to spawn them on this very specific board, and then we're going to position them at the proper place. So we're going to get started right here by creating ourselves a new script that I'll call chess pieces. And under there, I'll create a C# script that's going to be the chess piece, like that. This is going to be the base class, and then all the other object will inherit from that. So this base class, I'm going to make sure to clean it up completely. And then inside of here, I'm going to keep mono behavior actually, so we're going to need to have a Unity engine as well. And actually, before I start defining a little bit more what a chess piece is, I'm going to create myself a new enum class here. So public enum that I'll make, I actually call chess piece type. Because there ain't much chess piece type, right? We have the pawn. Actually, let's start with none. It's always good practice to start with none. So then we have the pawn. Then after that, we have the rook. I'm going to go in the order in which we start from the pawn and then from left to right. So pawn, the rook. We have then the knight, bishop. And then here that would be king, but let's keep the king for last actually. So here's my order. Like that. Queen and then king finally, number 6. Now with this in mind, I'm going to be able to go here under the chess piece and create myself a public chess piece type. And this will be useful later on when we do checks, especially to know if this is the king or not. So I'll just call this one type. I'm also going to need more information per pieces. One of them is going to be the team, and I'm going to store that in the int value, where the white team is going to be 0 and also the black team is going to be black. The 1 is going to be black is what I meant. We could also be storing that inside boolean or a bit or whatever really. Next up, I'll be keeping track of my current x and also my current y, just like so. And I believe is that all we need for every single pieces? This is all we need for the basic logic, but just for the sake of polishing things a little bit, I'll create two more values, two vector 3. One of them is going to be the desired position, and the other one is going to be the desired scale. And what we're going to do with these is basically lerp the position in which we are right now and the position where we should be in the future, which instead of just snapping our objects around, we are going to be moving them in a smooth manner. Same thing for scale. Now, the only moment where I'm going to scale down or scale up pieces is when they die. So when they get eaten, I'm going to scale them down and just put them aside. That's the only purpose that this value exists right now. At the moment, because I'm just doing spawning, I'm not moving things around and I'm not doing anything fancy like checking for special moves. At the moment, this is going to be enough, but eventually we're going to come back to here and create at least a minimum of 2 virtual functions. One being get the available move for this piece and also get the available special move for this piece. As you understood, this is going to be the parent class, so every single children will be able to override that. And we are actually going to create those childrens right now. So under the chess piece, I'm going to be creating myself a new C# script, and I'll just call it pawn. Now it's going to be very important that we go under every single one of these that we create and make sure we inherit from chess piece. And then I'll just clean up the whole thing, like so. So we have our pawn. We're going to have our rook. And I'll do it quickly here because every time I create something, the editor pops up again. Next up is going to be the knight. The bishop. The queen, and finally the king. Oh, wrong folder. And let's go ahead, open all of these scripts that we just made and make sure we replace, make sure it inherits from the right things. We have the rook, the queen, pawn, knight, king, and bishop. Now all of these are open. I'm gonna go ahead and make sure I change all of them. So chess piece, same thing for the king, same thing for the knight, same thing for the queen, and I believe we are done after the rook. Alright, so now all of my piece inherit from chess piece. It's not going to be useful as of right now, but at least now we have different script on every single object. Speaking of these objects, we need to create them. So I'm going to go ahead, create myself a new folder called Prefabs, and I'll drag the art for every single one of these into my board right now. If you don't have art for every single one of your piece, then try to create some different primitive object, and you can then assign those primitive object the script that we just made, and then save them inside of the prefab folder. So in my case, it looks something like this. So I drag the bishop, the king, the knight, the pawn, and the queen, and the rook, and I'll drag and drop that inside of my prefab folder. I want to be doing the prefab, actually the original prefab, and make sure you also assign them their script. So this is the rook. I'm adding the rook script to it. Then I can finally delete. This is the queen script. And don't worry about the type values right now. We're going to assign them through script, so it's going to be a little bit safer. Same thing here for pawn. Oop. Same thing for knight. King. Bishop, and I think we're done. Okay, so the actual boring work is done. We can now move on to some scripting. Alright, so what we'll need to do is go under the chessboard and start defining a couple of fields for that. So we have the art stuff, but on top of that, we are gonna have the prefabs and material, which I guess could be the art stuff as well. But in here, what I need is actually two array. Those arrays are going to be a game object array for the prefab and also a material array for the materials. So I'll start with a deserialized field, actually serialized field, private game object array, and this is going to be the prefabs, and then another one for the material. Actually, this is the team material because both team are going to have a different material. This is going to be a material array as well. Okay, now if we quickly tab out, we should be able to see these pop up under our chessboard object. So here they are. I'm gonna go ahead and say, what are my prefab here? I have a total of 1, 2, 3, 4, 5, 6. I have 6 different pieces, so put them there. And then the team material, I only have two teams. So let's go ahead and assign these. Now the way I'm gonna do it is by using the int they have assigned in the enum. So if I have a look at my enum under chess piece, I have them in this order, so pawn, rook, knight, bishop, queen, and king. And I'll just drag them here as well in the same order. And do note that here we have a 0, so we'll have to circumvent that or remove the none if you wish. That could also be an option. But here what I'll do, pawn into a rook, into a knight, into a bishop, I believe, queen, and then king. Alright. Now for the material, we don't have material right now, so let's go ahead and create 2 of them. So create new material. I'll call this one white team, and I'll just leave it like that. And I'll make another one for black team. And just do the normal material, but then with this black color on top of it. Okay, drag and drop these 2. So black is 1 and then white is 0. We can then start spawning them through code, which means we are going to go back on the chessboard and start defining a new section here. We have the generate the board, we have the operation. Here we're gonna have some spawning of the pieces. There we go. Now just like we've done with the tiles, we're gonna have a function that spawns all of them, and then a small function that helps you spawn one of them at a time. So here's what we'll do. Private void spawn all pieces, Do we have any constructor in there? No, no signature, so we'll just leave it like that. And then the other function is going to be spawn single piece. The spawn single piece is actually going to return a chess piece, and it's going to take in a chess piece type. So we'll do chess piece type, and then the team as well. Alright, so which one should we do first? We are going to do the spawning a single piece first. It's going to be quite a simple one. We first start by defining a new chess piece, so CP is going to be equal to instantiate, because we're using prefabs here. We're going to instantiate prefabs, which is the list of prefab we just filled in, at the index int type. But then we had a 0 in there for none, so we're going to do -1, so we're in sync with the array. So we're going to be spawning that. The transform parent is going to be ourself, so transform just like this. And then to make sure we have the chess piece type, actually the chess piece reference, we're also going to do a get component on that very same line. So by doing this, we are spawning a piece with the instantiate, but then we're also getting the component chess piece inside of it as we spawn it. And then we can, return that CP. But before we do so, let's make sure we actually assign it the right value. So cp.type is going to be equal to type, and cp.team is going to be equal to the team that we are receiving in parameter right here. So that's the reason why we couldn't just put the information in the prefab, because the prefab doesn't know which team it's going for. So there it is. Oh, and on top of that, we could also get the component of mesh render and change the material. I forgot about that. So material is going to be equal to team materials at index team. All right. So that's if we want to spawn a single piece. And if we give it just a try, I'm going to go under the awake and say spawn me a king for the white team, which is index 0, for example. Let's see what happens. And as you can see here, we have a king right here in the middle. It has the right prefab, has the right team, and the right type as well. Okay, going back on my script, it's now time to spawn all the pieces. Now, in this first section, it's going to be quite simple. We're spawning a standard chessboard, but in the third section, the one that is being unlocked a little bit later on with the 10,000 subscriber thing, in that one, we are going to be able to pick from different layout in the menu. So just assume that in the menu, we're going to have a scriptable object in which you can decide, hey, I want to have this board right here, or I want to save like a previous session I had with one of my friends, and those are where the pieces are, and this is what we're going to be spawning. But for the first section, we're spawning a standard chess. Yeah, standard chess opener, I guess. And we're going to do so by first creating the most important multi-dimensional array we're going to have for the whole tutorial. And it's going to be a chess piece array just like this. So multi-dimensional because we're having a grid of X and Y. And it's going to be called chess pieces. Those are all going to be the active chess piece on the board right now. And we're not going to assign them right here because instead we're going to assign them when we spawn them. So this is a new array with tile count X and also tile count Y. We are not going to have as many pieces as there is tiles. However, we're going to leave the chess piece on null if there's nothing there. So as you can see here, we instantiate this, and then what we have to do is define where every single one of these pieces are going to be. But before we do that, I'll get myself some helper values. So white team is going to be equal to 0, and then black team is going to be equal to 1. I'm defining them all on a single line. You could put them on different line if you don't like this way. So this is the layout we're going to be using, the standard chess. We're going to have the white team at the bottom right here in the 0, 0 index, and then the black team here at the top. And I'm going to start right away with the white team. So chess piece at the index 0, 0 is going to be, I believe, a rook. So it's going to be equal to spawn piece, spawn single piece type of. This is going to be a rook for the white team. And we're going to be copy and pasting this quite a lot. So right next to the, oh, wrong way here. Right next to the rook, there's going to be a knight. Right next to the knight, there's going to be a bishop. Next to that, there's going to be, I believe, the king. into the queen, into another bishop, into another knight, and into the final rook. Now we're going to go ahead and increment that by 1 every time. We should have up to 7. Here it is. And then finally, then we have to do the pawns. So here, for that, we'll do an array. We'll say, as long as it's smaller than tile count in X, we're going to do chess piece at the index I. And then here is going to be 1 because we're 1 step above the last one. We're going to be spawning pawn. That's what I meant to write. Okay. Just to make sure we didn't make any mistake, let's go ahead and take this spawn piece and let's put it here at the top in the awake instead of what we had earlier, right? So instead of spawning a single piece in the middle, a king in the middle, we're going to be spending the whole, we're going to be spawning the whole white team right here. So giving this a try. And it's all there. It's just positioned very poorly, but it's all there as you can see, and we should be able to find them here. So rook, there's a total of 2 rook, 2 knight, 2 bishop, king, and queen. So here they are, and a total of 8 pawns. Cool, everything works. So I'm gonna go ahead and duplicate this for the black team real quick. The only thing we have to change really is the axis in which this is being spawned, not the axis, sorry, but the y-axis here. So all of this turns into 7, and all of these turn into the black team. Now don't forget to do that for the pawn as well. And 7. Actually, sorry, 6 here, because we are 1 step beneath what we were. Okay, this is good. Looks like we have all of these pieces being spawned. The next step is the last section of this video. It's going to be about positioning all of them at the proper place. So this part will be done through a couple of different functions, and the reason I'm going to be splitting things as much as I will is for the sole purpose that we want to be able to reuse just part of these functions in the future. And I'll show it to you right now by creating a new section called positioning. We are starting with a position all piece. Position all pieces, which we're going to be following the same exact concept as we've done above here. So every time that we do one of these sections, we do it for everything and then for a single piece, for example. So here is position all piece, and then beneath that, it's going to be position single piece, which is going to be taking in the x-axis, the y-axis, and also a boolean that I'll call force, but I'll default that to false, and I'll explain to you what it does in a bit as we go through it. But first, when I want to position all the pieces, I'm simply going to iterate through all the pieces that exist right now, and I'll call the position single piece. Here's what we do. We're going to do a for loop on every single chess pieces. I don't want to do dot count here. We're going to do tile count.x. Let's also change that to x. Yep. Let's do y here. And tile count y. And then inside of here, it's very important that we check if there's something there in the first place, because if we try to position a piece that doesn't exist, we are going to crash. So we're going to say if chess piece at the index xy is not equal to null, then we're going to go ahead and... Hey, peeps. Sorry about that. My dog he sees another dog outside and he just cries. Position single piece. We're going to call position single piece with x and y, and we are going to... We're going to force here, so we're going to say force. Now, I'll explain that what it does right now, because I want to tell you why I put through here. The force value is going to be, so when you call position single piece, you'll have the option to have the piece teleported instantly where it should be, or you'll have the option also to have it smoothly move from one place to another. So for example, if we're making a move from in the middle of the board to somewhere there, then I don't want to call force because I want the piece to drag itself slowly across the board and go there, like a real movement. But when I'm spawning initially, and like we're gonna have all the pieces in the middle, like right away, like the 16 times 2 pieces, 32 pieces in the middle, I don't want them to all go smoothly to their spot. I want them to appear exactly where they need to be. So that's what I do here. So when I call position all the pieces, I want them to snap exactly where they're going to be when the game starts. Alright, next up we have the position single piece. Here what we'll do is we'll say chess piece at the index xy dot current x is going to be equal to x. So we're actually setting the data behind it first before I go ahead and actually move this object, this game object dot transform. Now we're going to go ahead and call the transform of that piece. So we're going to move the transform of that piece. Eventually I'm going to change that just a little bit, but initially I want to show you what it does. So chess piece transform the position, and we're going to say we're going to move that to, for example, vector 3 x time tile size. If you don't have the tile size value, it's actually something we set in the third section of last video, in which we define what is the size of a tile. So we also changed tile style here that we had at the top. We also changed it inside of the awake. So generate all tile now has the tile size in it. It was important for us because we have different artwork, and the artwork tile size is not exactly 1, but it's 0.7 in our case. So I've changed that to 0.7 in my case, and here I can say my new position is going to be at x tile size. The y offset, also very similar to the value I just mentioned. It's just that my board in my art has it has a pivot point, and then above that it has the board itself, which takes a little bit of space in a y, and that's what this value is. And finally, y times tile size. Okay, so we're gonna do this just to see if the placement is correct, but there's gonna be a certain offset that we will fix in a moment. As we can see, nothing happens because we didn't call the function. So let's go ahead and call position all the piece in our awake, after of course spawning them. Now I'm gonna hit play, and here they are. So they are looking good. They're just looking very offset right now. So as you can see over here, we have rook, knight, bishop. This is the queen, king, and it's the right order. Is it the right order on this side as well? I believe so. They just have some orientation issue which we can fix in the future, but right now this seems to be looking quite good. All right, now the big offset problem we had is because we're not subtracting our bounds that we had earlier. So I'm just gonna do it real quick just to show you what is our new problem basically. But as you can see, now they're at the proper place, but they're not directly in the middle of the tile, which is the problem. So what we're going to be doing next is, instead of calling this right here, I'm going to create myself a new function that returns a vector 3, and I'll call it get tile center. This one's going to receive in parameter a x and also a y, so for the offset. And here's the formula I'm going to come up with. So vector 3, x times the tile size, the y offset, and the y times tile size. Exactly what we had prior. Then I'm going to do minus bound, also exactly what we had prior. But then we'll do plus a new vector 3, and we'll do tile size divided by 2, and also 0 and tile size divided by 2 once more. And we can then replace this with our new function. And just like that, I believe we should be able to get something that looks a little bit better. Alright, and now it's perfectly placed. There is one problem with that we don't see right now, but we'll see once we start moving pieces around. If we move pieces around, they're going to be snapped directly. So we're not using the force value here at all at the moment, but it's something that we'll see in the next episode. So it's going to wrap up pretty much all we've had to do today. It's looking a little bit better. Of course, we have couple of tweaks to do. For example, we need to fix the shadow, the lightning. We could do a skybox as well. Since we're here, let's go ahead and do that. I'm just gonna do a material for the skybox. I'm gonna do something procedural for the moment. So I'll just call this one skybox and switch that over to skybox procedural. Drag that on top of my world, and then I can play around with this with whatever color that you feel like. To be frank, I'm just gonna go with these very pink color. I just like having a bright screen in this case. But yeah, and also the directional light, as you can see, causes a lot of shadow issue, but you want to be able to play with that as well. Another thing that you could play with to make your game look a little bit better at the moment would be the material. So the team material right here, they could use something, for example, they could be a little bit more metallic or smooth, or you could have your own material that makes this look good actually. One thing that is cool with material is that you get to actually see the change as the game is running. So you can play the game, which is something that you need to do to see those pieces because they are generated at runtime, and you can actually swap the material. So that's what I'm doing right now. I got a black team that looks quite good. I'm gonna go ahead and look at the white team right now, change a couple of things as well. I'm gonna go with speculars, and I won't receive shadow. I actually don't like the shadows unless we want to put a really high quality shadow. It's something we could do as well. Those settings are all under our artwork, actually no, config, and the pipeline assets. So you'll be able to find quality setting here, such as the shadow. We can increase the distance at which we see those shadow. We can turn them into soft shadows, which could actually fix this issue and make it not look too bad. And I believe that we also had quality of those shadows somewhere. Oh, under lighting here, they are under the shadow resolution. So if you want to have crazy high shadows, it's just a simple chess game. But if you want to do that, you can also find that here. But yeah, so go ahead, play around with that. Just make it look good. And that's going to be wrapping up our second episode of the chess game. In the next one, I believe we're going to be starting to pick up these pieces and make them move. So it's going to be quite interesting. So thank you very much for watching. I hope you enjoyed this series thus far. If you do, please leave me a like, leave me a subscribe. That'd be really appreciated. The dog also would like that. And yeah, so it helps me make more content basically. And as mentioned earlier, the second part will start coming out as soon as we have 8,000 subscribers. So please help me get there. And that's pretty much it. I'll see you soon. Thank you so much. Cheers.